Hi friends, today let us discuss Bayes' theorem. So before discussing Bayes' theorem, we have to recall what we have studied in our previous classes. That is, first one normal probability and second one conditional probability. And then we will arrive at Bayes' theorem. So first of all, let's see what is normal probability. Okay. And suppose there are two boxes, box A and box B. And what is the probability of choosing box A, that is probability of box A? Since there are two boxes, it will be 1 by 2. The 1 denotes A or B and 2 A and B. Okay, and what will be the probability of choosing box B? It also will be 1 by 2. And suppose there are three boxes. Suppose there are three boxes, box A, box B and box C. Now, what is the probability of choosing box A? Since we have three boxes, it will be 1 by 3. Likewise, probability of B will be 1 by 3 and probability of C will be 1. Okay. And when you add these probability together, you will be getting 1. Okay, that is the value of probability will be 1. And suppose a question is asked like this. Suppose probability of A is equal to 60% and probability of B is equal to 30% and probability of C is equal to 10%. So what does it mean? It means that probability of A is equal to 60 by 100 is equal to 0.6 and probability of B is equal to 30 by 100. So it is in percentage, so we have to convert then 0.3 and probability of C is equal to 10 by 100 is equal to 0. So this is the case of normal probability. Second one is conditional probability. Okay. So in conditional probability, we have an equation, or we can find it by logic, or we have an equation, that is probability of A given B is equal to probability of A intersection B divided by probability of B. That means, what is the probability of A given that event B has already occurred, or selecting elements, that is A, selecting elements from, that is given B, or from B, and this is conditional probability. Let's see one example. There is a question. There is a box containing 5 red and 2 white balls. Find the probability of selecting red balls. Selecting red balls. What is the probability of selecting red balls given there are 7 balls? Selecting red balls. Okay, and since we have only one box, it is very simple. So given that B means the box containing 5 red and 2 white balls. So what will be the answer? Selecting red balls. So there are how many? 5 red balls out of box containing 5 red and 5 red and 2 white balls, that is 7. Okay, so 7 balls. So this is the conditional probability. We have a very simple conditional probability question. So I just want to make clear the concept. That's why I have chosen this example. So thus, in simple words, what is the probability of selecting 5 red balls given that the total number of balls are 7? So now we come to Bayes' theorem. So in Bayes' theorem, it is just different from conditional probability. For example, probability of x given a. That is what we have seen in conditional probability. But here we are using probability of a given x. It's an opposite, a given x. So what does it mean? We have an equation that is probability of x given a into probability of a, and suppose there are 2 boxes, then divided by probability of x given a into probability of a plus probability of x given b into probability of b. In this case, we have only 2 boxes and we are choosing some, for example, choosing red balls or something. The condition or the elements that we are choosing. Okay, it is denoted as x. And now suppose there are 3 boxes. Then probability becomes a given x equal to probability of x given a into probability of a, all divided by probability of x given a into probability of a plus probability of x given b into probability of b plus probability of x given c into probability of c. So this is our equation for Bayes' theorem. I think you may find it difficult when you see this equation and all, but it is very simple. And let's see next sample. Box A contains 2 white and 3 red balls. Okay, 2 white and 3 red balls. And box B contains 4 white and 5 red balls. One ball is drawn at random from one of the box. We don't know which is the box, and is found to be red. The ball was found to be red. Find the probability that it was drawn from second box. Okay, so it is not conditional probability, it is Bayes' theorem. Okay, read the question once again. So from the question, there are 2 boxes. Okay, box A and box B. So there are 2 boxes, A and B, and there are 5 balls in box A, that is 2 white and 3 red, and there are 9 boxes in box B, that is 4 white and 5 red. So first of all, let's see the question once again. We have to find, we have randomly chosen one red ball, and the question is, what is the probability that it was from the second box? So before that, we have to see the normal probability and conditional probability before finding the Bayes' theorem. So what is the probability of choosing box A? Probability of A, we have only 2 boxes, so the probability of A will be 1/2. And what is the probability of choosing B? And this one also will be 1/2. This is our normal probability. Okay, and let's use the conditional probability. So our question is choosing red ball. Probability of choosing a red ball from box A. What is the probability of choosing a red ball from box A? So in box A we have 3 red balls and there are only 5 balls. So 3/5 will be the probability of choosing red ball given it is from box A. And what will be the probability of choosing red ball from box B? have 5 red balls and total balls are 4 plus 5, that is 9. So this is our probability of choosing red ball from box A, that is and 3 by 5, and probability of choosing red ball from box B and 5 by 9. So I would like to note down the results that we have found. That is, first one, probability of A is equal to 1 by 2, probability of B is equal to 1 by 2, and probability of R, red ball given, is from box A is equal to 3 by 5, and probability of choosing red ball from box B is equal to 5 by 9. Okay, these are the results that we have found. And when we come to conditional probability, the question is reversed. Actually, the question is reversed. That is, what is the probability of choosing the red ball from box B? So the question becomes B given R. So it is from box B given that we have found or drawn red ball. So by definition of Bayes' theorem, it is probability of R given, that is red ball given from box B, into probability of box B divided by probability of red ball given from box A into probability of A plus probability of red ball choosing from box B into probability of B. Okay. So let us apply our values. That is, probability of box B given, that is red ball, is equal to R given, that is we have 5 by 9 into probability of box B 1 by 2 all divided by 3 by 5 into 1 by 2 plus 5 by 9 into 1 by 2. So it is 5 by 18 92 divided by 3 by 10 plus 5 by 18. Okay, and when we do the cross multiplication, we will get divided by 3 into 18 plus 5 into 10 all divided by 10 into probability of we have 5 by 18 all divided by 3 into 18 54 plus 5 into 10 50 divided by 1 or equal to 5 by 18 and taking it 1 by 80 divided by 4. Okay. So we have 50 by 104 25 divided by 52. Right. 50. This is the final answer. So I hope it's clear, and let's do one more example. So we have one more question. 3 machines A, B and C produce 60%, 30% and 10% item respectively. But some products are defective. So the defective percentage are 2%, 3% and 4% respectively of these 3 machines. And find the probability that items were produced by machine C. So read the question carefully. So I have summarized the result, that is machine. There are 3 machines A, B and C, and the produced items percent by percentage 60% from A, 30% from B, and 10% from C. And defective products percentage are 2%, 3% and 4% respectively. So let's convert this into probability. That is, probability of A is equal to 60 by 100. So it will be 0.6. The probability of B will be 30 by 100, that is 0.3. And probability of C, that is from machine, produce item from machine C, it will be 10 by 100 is equal to 0.1. So this is the normal probability case. Okay, and let's see the conditional probability. That is, there are some products are defective, then it is from machine A. That is probability of defective product produced by machine A is equal to 2 by 100. That is 0.02. And probability of defective products produced by machine B, it will be 3 by 100, so it is 0.03. And produced item from machine defective products produced by machine C is equal to 4 by 100, so it is 0.04. So these are the normal probability and conditional probability of this question. So our question is, what is the probability of the defective products that is produced by machine C? Okay, so that is C given produced machine C and products were defective. So the case once again, and we will be getting the clear picture. So what we have an equation. We have to rewrite the equation. What is probability of defective product given machine C into probability of choosing machine C, all divided by probability of defective products machine A into probability of A plus probability of defective products given machine B into probability of machine B plus probability of defective products machine C into probability of C. Okay, and let us apply all these values here. That is probability of B given C 0.04 into probability of C, and probability of C is equal to 0.1 divided by, we have 0, here we have probability given A is equal to 0.02 into 0.6 plus 0.03 into 0.3 plus 0.04 into 0.1. 04 divided by 0.025, and your final answer would be 0.16. Okay, or approximately 0.16. So you just do the question. So hope that the Bayes theorem is clear for you. Enjoy life and keep learning.